Hello, and welcome to our first video of the Systems and Changing Momentum with Forces unit. This particular video is on systems and changing momentum. The essential question for this video is, how can we describe an object with changing motion using momentum in open systems? So far, we've noticed that objects' momentum changes when they collide, and now we're kind of interested in zooming in and figuring out what's happening during that very short time interval while the object's momentum is actually changing. So in this unit, instead of using the plain P that we were using in the last unit for momentum, we're going to be almost exclusively using DeltaP, which is change in momentum. And that's an important difference. If you mean to write DeltaP and you write P, you're telling me something completely different. So DeltaP is the variable that tells you if an object's momentum is changing or not. That DeltaP could be any value. It can be 0, it can be positive, or it can be negative. If you happen to have a DeltaP value of 0, what that means is the object is at a constant velocity. There's a common misconception that that means the object is stopped. It's not, doesn't have to be stopped. This could be an object that's moving or standing still. Of course, that tiger laying at rest has 0 momentum, and if you ask me again 5 minutes from now, if he's still there laying at rest, he has 0 momentum. That means DeltaP is also 0 because it didn't change from his resting beginning. So this object is at rest and has a DeltaP of 0. But take a different object like a car moving on the highway. That car might have 100 kilogram-meter per second of momentum, but if it's at a constant speed, 5 minutes later it still has 100 kilograms meters per second of momentum. That means the DeltaP for the car is also 0. So it doesn't have to be a resting object, it just has to be moving at a constant velocity to have a DeltaP of 0. If the DeltaP is not 0, so if it's a positive value or a negative value, what that means is that the object's velocity is changing. It's either slowing down or it's speeding up. If you have a very small DeltaP, a DeltaP of 0.2 or 1, that means that the speed is just changing by a little bit. So my momentum is not changing dramatically. So for example, this snail is not changing momentum much when it starts moving because it's a very small object and not going to change momentum very quickly. And this soccer ball also is going to have a relatively small DeltaP, because even though it's moving much faster than the snail, it doesn't slow down very quickly. It kind of moves at the same speed, it rolls at the same speed, slowing down slightly but not changing dramatically. If an object has a large DeltaP, it generally means that the speed of the object is changing a lot. So this race car is speeding up pretty dramatically at the beginning of a race, right? Speed is changing a lot. It's going to have a large DeltaP. And this space shuttle, as it's landing, it's got that parachute out, that's going to have a large DeltaP also, because it's slowing down from a very fast speed very quickly. So the magnitude or the size of the DeltaP tells me, generally speaking, how dramatically the speed is changing. Let's look at a quick example of an object of a person skydiving from a hot air balloon, and take a look at how the momentum of that person is changing and what DeltaP values we would expect as that person falls. So the very first situation is the skydiver standing still in the balloon. It's just waiting to jump. And in that case, before the skydiver jumps, DeltaP is going to be 0 because he is at rest in the balloon. He's just standing there. His velocity is 0 and it doesn't change. So where DeltaP is also going to be 0. Then the skydiver jumps out of the balloon. And in this case, he's going to have a large negative DeltaP because he is becoming faster and faster in the negative direction, which is down. He's gaining negative momentum. So he's speeding up, but notably it's a negative DeltaP, which is okay as long as his velocity is getting bigger and bigger and bigger. If we go from a momentum of -5 to a momentum of -30, DeltaP is going to be -25, and that object is actually getting faster and faster and faster. So don't confuse the negative DeltaP with slowing down. Negative can mean speeding up if you're already moving in the negative direction. Then that skydiver is eventually going to open up his parachute. And when the parachute opens, his velocity is actually going to slow down. Another way to look at this is his velocity is becoming less negative, because if he was going at negative 30, then he's going to go negative 25, negative 20, as he kind of reaches a safe speed. So when his velocity is becoming less negative, that's actually a positive delta P. And this is probably not going to be as large of a delta P as we noticed in segment number 2, because his speed isn't going to change quite as dramatically. So he's going to have a positive delta P when he's slowing down. Again, positive doesn't have to mean speeding up, but his velocity is becoming less negative as he slows. Eventually, this parachuter is going to settle into what's known as terminal velocity, which is a constant speed, and he just then will kind of cruise until he hits the ground. And during that constant velocity portion, where he's just floating down at a constant speed, delta P is 0 again, and this is an example of when you might be moving but still have a delta P of 0 because you're moving at a constant velocity. So his momentum doesn't change during that time, it's actually just constant. Hopefully you're thinking a little bit about systems as we go through this. What kind of system is the skydiver? Compared to our collision systems earlier, you may have thought that during phases 1 and 4, when the skydiver's momentum is not changing, we could consider the skydiver a closed system during those 2 phases, because the momentum isn't changing. Nothing's going in or out of my system. What you'll discover in the next video is this means that forces that are acting on the skydiver during those intervals have to have been balanced out by equal and opposite forces. So it doesn't mean that there aren't any forces on the skydiver during phases 1 and 4, but it does mean that those forces have to be balanced out by other forces. Otherwise, the momentum would be changing. During the second and third phase, when that skydiver was speeding up as he fell and then slowing down as the parachute opened, the skydiver's momentum was changing, so he would be considered an open system during those times. And what that means, of course, is that there are unbalanced outside forces, specifically gravity and the air resistance from the parachute, that were acting on the skydiver and changing the skydiver's momentum. So that skydiver was at times a closed system and at other times an open system, meaning that momentum sometimes stayed the same and sometimes changed. So please take a moment in your notebook and think about our essential question from the beginning. How can we describe an object with changing motion using momentum and open systems? What is going on, and what does a large and a small and a positive and a negative momentum mean about objects? Thanks for watching.